we're talking about relays. We'll start with our heat sequencer relay, gets our white wire. What we have to understand about a relay is a relay has a space for low voltage connections as well as high voltage connections. So every relay will have a space for low voltage and high voltage. This is our heat sequencer. This is what it looks like on the diagram. Heat sequencer has low voltage connections along the bottom, the base. The heat sequencer gets the white wire from the thermostat. The heat sequencer provides power to the heat strips. Now, as we learned in the previous lesson, we're always gonna have our 12 volt low voltage common and our 12 volt control, okay? Every relay has two hands. If you look, every single relay has two hands for the low voltage. So one side is gonna be our low voltage common. Low voltage common. So if this is our low voltage common, then obviously the other one has to be low voltage control. We talked about colors. We'll get a blue out. We know that this heat sequencer will have half of its low voltage is going to get a blue wire. A blue wire. That means that the other side of the 12 volts is the control. And this is what goes to the thermostat. We're gonna go over each relay, then we'll put them on the board and see how they work together. Heat sequencer. High voltage connections on the top. Once the low voltage gets 12 volts from each side, gets its 24 volts, what happens is there's a little bimetal in here that floats up. It takes a few seconds. It's about 15 to 20 seconds. This little metal, once it gets 24 volts on each leg, this bimetal will float up and then connect these two connections. Same thing, when the voltage is taken away by the thermostat, that bimetal will take a few seconds to float down. The reason we do that is we want to sometimes delay something turning on or off. But this is our first relay, our heat sequencer. 12 volt common. Common, common, common. Let's go with our reversing valve. Reversing valve goes outside. It gets the orange wire from the thermostat. It changes the cooling mode into heat pump mode. So whether you have a straight cooler or heat pump depends if you're gonna have a reversing valve. And again, a relay is a relay is a relay. Every relay has a low voltage control. So we're gonna find the common. We're gonna make that blue. Blue all day. Just blue because common gets its blue. We're gonna go past the reversing valve. Compressor contactor. This is the other relay that's outside in the condensing unit. Looks a little complicated, it's not. Let's look at the real one. This is a compressor contactor. First thing I want you to notice is that it's split down the middle. You see that? There's a plastic wall that prevents this voltage to jumping over into this voltage. So even with a compressor contactor, you can think line 1, line 2, because 240 volts flow through this contactor. How do they flow through? Because we have middle low voltage connections right here and right here. This is where the low voltage goes. And then your high voltage comes in through the bottom, 120 on L1, and it comes out the other side, 120. Comes in one side, 120, leaves out the top ones, 120. The reason we have multiple plugs like this is because in the condenser, we're gonna have a fan that needs this leg of power, a compressor that needs this leg of power. Sometimes there's other things in higher end systems that'll need more legs. But that's why we have multiple legs. And as you see, if you connect one to this leg, it's gonna be connected because these metals go all the way through. So when low voltage is applied to the sides, middle, low voltage connections, there's a plunger that falls down. This falls down, this plunges down and makes contact and then continues the circuit so the voltage can flow through. The reason this works is there's a coil on the bottom. And once it's energized, it pulls the plunger in and completes the connection. This is your compressor contactor. Again, just like any other relay, find your low voltage connections and designate one low voltage common. And what color is low voltage common every time? Blue. For the purpose of this diagram, it's gonna be blue. In the field, sometimes there is a different color, sometimes it's brown, depends on the machine. For now, we focus on blue. Blue is the low voltage common. Common leg, common, common. Again, a relay is a relay. Every relay has a low voltage common. We got the low voltage common 12 volts on the low voltage control. Both meet here. The plunger drops and power is streamed through the contactor. And this is the contactor. This is what turns on the compressor and the outdoor fan motor. This compressor contactor is in the condensing unit, not in the air handler. Moving on. Let's go to our fan relay. This is inside of the air handler. This is what controls the indoor fan motor. Fan relay gets the green wire. The high voltage connections are at the top. When you look at a fan relay, you'll see 4 connections or sometimes 3. And these will say, and then this is where you know your 120 volts goes through. Your fan relay is just going to break one leg. So it's 120 that's going to jump over. When does it jump over? When we get 24 volts to the low voltage connections down here. So low voltage connections, a relay has a low voltage connection. It has 2, 12 volts on one hand, 12 volts in the other hand. Try to think of your low voltage connections as 2 hands. You have 2 hands. Every relay has 2 hands of low voltage. 2 hands, not 1 or 2 or 3, but 2. Okay, so with this, what are we gonna do? We're gonna designate a 12 volt common. And of course a control. What color is common? All day with us, it's blue. So now this fan relay is ready to accept 12 volts common and 12 volts control to turn on this connection and to bridge this gap and send 120 volts to turn on the fan. This is our fan relay. So going over our relays, fan relay for the indoor fan motor inside the air handler. Compressor contactor, low voltage connections in the middle, common on the left, outside condensing unit to power up the compressor and the condensing motor. Reversing valve, 12 volt common, 12 volt control, gets orange from the thermostat, changes the system from cooling mode into heat pump mode. This is outside at the condenser. Finally, our heat sequencer gets the white wire, 120 volts, connections along the top, low voltage 24 volt connections on the bottom, low volt common is blue. These are our basic relays. Now let's put them on the board.